Welcome back. Problem 12.7. So statement is the beam is made of two rod and is subjected to concentrated load P. Determine the maximum deflection of beam if moments of inertia of rod are IAB, IBC and the modulus of elasticity is E. So you can see this is the beam that is made of rod AB and BC. The total length of this rod is capital L while length of this BC is small l, and there is a concentrated load at point C. So you have, due to this load, this beam will deflect like this. So you have to find this maximum deflection. So let's start with the solution. So first, if you take this beam and you cut it over here, let this distance from this end is x1. So if I draw the free body diagram, so it will be like this one. There is a P load clear at this point and this distance is taken as x1, and when you cut it there will be a shear force V. Okay, this force will be upward because this P is downward, so it will be upward, and there will be a movement. Let this movement is equal to m1 of x. So, and this is your point 1. So by applying equilibrium condition that sum of all movement about point 1 is equal to 0 and taking the counterclockwise movement as positive. So about point 1 we have external movement that is m1 into x, another movement is p into x1, and that will be clockwise direction, so it will be negative. So I will write m1 of x minus p into x1 is equal to 0. So from here this movement will be equal to m1 of x will be equal to this is positive because this is clockwise, this is clockwise, so it will be positive, and this will be this is clockwise, so it will be negative, and this is counterclockwise, this is also clockwise, so it will be also negative. So make a correction over here. Minus m1x minus p1 is equal to 0. So m1x is equal to minus p into x1. Now we know that E into I d square v over dx square is equal to mx, where v is vertical displacement. Clear? So in term of x1 we have ei into d square v1 over dx1 square is equal to m1 of x. So, and this m1 of x is minus p into x1. So integrate it once time, integrate it, we will get ei into dv1 over dx1 will be equal to minus p into x1 square over 2 plus c1. We will again integrate it. Let this is your equation number 1. So again integrate 1. We will get ei into v1 which divide by v1 is equal to minus px1 cube over 6 plus c1 x plus c2. Let this is your equation number 2. Now what we will do is that we will cut the beam over here. Let this distance from the start is x2. So we will draw free body diagram over here. We have a larger dia rod followed by a smaller dia. and here we have a load of P that is acting. Now this total distance is x2. So when you cut it, there will be a shear force V. This is capital V to integrate, or V at x2 you can say, and there will be a moment that is M. Let this point is 2, so M2x. So by applying sum of all moment about point 2 is equal to 0, taking the counterclockwise moment as positive. So you can see this is minus M2x because this is in clockwise, and minus P into x2. This is also in clockwise. So M2x will be equal to minus P x2. Now you can put it in this equation of slope and deflection. So EI for x2 we have d square v2 over dx2 square is equal to m2 of x, and this m2 of x is minus p into x2. So integrate this, we will get EI into dv2 over dx2 is equal to minus p x2 square over 2 plus c3. Let this is equation number 3, and this equation is for slope. Again integrating, integrate these 3 equations. So we will get EI into V2 is equal to minus P into x2 cube over 6 plus C3 x2 plus C4. Here this is x1. Okay, now we have, this equation is equation number 4. Now we have this 4 equation, and we have C1, C2, C3 and C4 are unknown constant of integration, so we will find them by using boundary condition. The reason for this portrait view is that we can quickly view all the equation on one page. So first boundary condition is that at x2 is equal to L, we have dv2 over dx2 is equal to 0. So you can see this is x2 start from here and it ends at here. So at x2 is equal to L. Clear? We have deflection here at this point is dv2 over dx2, and that will be equal to 0 because this is a fixed support. So what will you do is that you have to put in equation number 3. So when you put it in equation 3, so when you put x is equal to L v dv over dx, it will be 0. So it will be equal to minus p L square over 2 plus c is equal to 0. So I will write it, 0 is equal to minus p L square over 2 plus c3. So from here we will get c3 is equal to p L square over 2. Now we have c3, we will use another boundary condition. And what is that boundary condition is that at x2 is equal to L, we have deflection which is v2 is equal to 0. So again you can see this is the fixed support. So at x2 is equal to L, we have v2 will be also equal to 0, or deflection will be 0. So we will put in equation 4, because equation 4 is the equation of deflection. So at x is equal to L, this term will be equal to 0 and this term will be equal to minus PL cube over 6 plus C3, which is this one, into L plus C4. So I will write it, 0 is equal to minus PL cube over 6 plus C3 is PL square over 2 multiply by L plus C4. So when you solve this, you will get C4 will be equal to minus PL cube over 3. Now we have C3 as well, so we will move towards C1 and C2. So from continuity condition, I will also show you what is the continuity condition, is that at x1 is equal to x2 is equal to small l, we have dv1 over dx1 is equal to dv2 over dx2. So you can see that here this x start from x1 will start from here and x2 also start from here. When x1 is equal to x2 is equal to small l, so here you can see you will have the same slope, clear. So dv1 over dx1 is equal to dv2 over dx2. So this is the continuity equation. Also here at x is equal to x1 is equal to L and x2 is equal to L, we have v1 is equal to v2 because we will have the same deflection at this point. So this will be the another continuity equation. So what we will do is that we will you can use x is equal to 1, x1 is equal to L in equation 1. So concentrate on this portion, as well, because this we are interested to find out dv1 over dx1. So I will write dv1 over dx1 is equal to 1 over ei into p minus p x1 square over 2 plus c1, and c1 is not known. So what we will do is that you have to put x1 is equal to L, so minus p1 pl square over 2 plus c1 into ei. This will be equal to dv1 over dx1. Similarly, at x2 is equal to L, you can use this equation number 3. So dv2 over dx2 will be equal to 1 over ei into minus pl square over 2 plus c3 is pl square over 2. So it is given that these two are equal, so we will equate the right hand side of this equation with the right hand side of this. So I will write it 1 over this x1 will for IAB, because you can see here this one is for IAB and here this one is R for IAB. This one is IAB and this one is BC. So I will make a correction. The first one is for IBC into minus PL square over 2 plus C1 is equal to 1 over EIAB into minus P L square over 2 plus PL square over 2. Okay, so this is P into L square over 2. Let me check it. P small l. Okay, so you can see this is small l and this is capital L. So after solving this 1 over e will cancel with each other, so we will left with C1 will be equal to, after solving it you will get C1 is equal to IBC over IAB into minus PL square over 2 plus P capital L square over 2 plus PL square over 2. So this is the value of C1. Okay, we will put another boundary condition that I have already told you, that at x1 is equal to x2 is equal to small l, we have v1 is equal to v2. v1x is equal to v2. So again you have to do the same thing, that what you will do is that you will find v1 from this equation and v2 from this equation, and then you put x is equal to L, which is equal to x1 is equal to x2. So after putting that, you will be able to do this. This is very easy. I will just straightforward put the value in equation 2. If x1 is equal to L in equation 2, and we will get v1 is equal to 1 over e1 eibc into pl cube over 6 plus c1, which is ibc over iab into minus pl square over 2 plus PL square over 2 plus PL square over 2 into x, which is L plus C2. So this will be the first one. At x2 is equal to L, when you put x2 is equal to L in equation number 4, so you will get v2 is equal to 1 over EIAB into minus PL cube over 6 plus PL square into L divided by 2 minus PL cube over 3. So equate this equation, V1 is this one and V2 is this one. So you have to equate these two, so you will get C2 as well. So I will equate this, V1 is equal to V2. So V1 is again 1 over EIBC into minus PL cube over 6 plus IBC over IAB into minus PL square over 2 plus PL square over 2 plus PL square over 2 into L plus C2 is equal to 1 over EIAB into minus PL cube over 6 plus PL square L over 2 minus PL cube over 3. Okay, so when you solve this, you will get C2 will be equal to IBC. You can do it by yourself. This is very easy. IAB into PL cube over 3. Some of the term will cancel each other. IBC into PL cube over IAB into 3 minus PL cube over 3. So this is the value of C2. Now you can see that we have C2, we have C1, we have C3 and we have C4. So we have been asked to find the deflection at this point, because the deflection will be like this one. So at x2 is equal to 0, we will use this deflection, equation number 4, because this is for x2, v2 will be maximum. So you have to put c3 and c4 in this equation and you will get v2. So what we will do is that put the value of c, okay, v1 equal to not, okay, make a correction. This is point v1, this is point x1. Sorry, we are interested to find out this, so here we will take x1 is equal to 0 in order to get. So what we will do is that we will use this equation number 2. So put the value of c1 and c2 in this equation. C1 is this one and c2 is this one in equation number 1. Put the value of c1 and c2 in equation 2. So when you put it, you will get v1 is equal to 1 over e I b c, and again you have to put all the values, p into x1 cube over 6 plus c1x. C1 is this above, this one is c1. So I will write it again, IBC over IAB. Indeed, it's a very lengthy problem, but you have to learn it. You have to practice it as well so that you have a proper holding on this problem. PL square over 2 into x1 plus c2, which is IAB, IBC over IAB into PL cube over 3 minus IBC into PL cube over 3 IAB minus PL cube over 3. Now maximum deflection at x1 is equal to 0. We have maximum deflection. I will show you. Here you have at x1 is equal to 0. You have a maximum deflection which is equal to Vmax. Also you can use x2 is equal to 0 as well, but for that you will then use this equation number 4 for finding the deflection. So here I have solved it for v1. So if you put at x1 is equal to 0, so v1 will be maximum. It will be equal to v1 at x1 is equal to 0. So so v max will be equal to, if you put x is equal to 0, x1 is equal to 0, so we will check this term will be 0. Clear? This whole term will be 0 because it is multiplied with the x, and we will left with this term. So this term will be 0 and this term will be 0. We will only left with this term. Clear? So after putting it, we will get, I will write the final equation, p over 3 ei ab, not sorry, let's do it step by step. Vmax is equal to I 1 over E I B C. Focus on this formula. 1 over IEBC IBC into this term will be 0, and we will left with this term will multiply with x1 with this term and x1 with this inner terms as well. So let me check it. So IAB over I minus PL cube. Okay, so definitely these terms will be 0 because they are all multiplied with x1. So we left with this one. So IEB, where I have written it over here, and the remaining term is IBC over IAB into PL cube over 3 minus IBC into PL cube over 3 IAB minus PL cube over 3. Okay, so you can take some terms common, and what you will get is that V max is equal to P over 3E IAB into L cube minus L cube minus IAB over IBC. I have already solved this. You will try it by yourself so that you can easily learn. So when you solve it, the final maximum deflection will be equal to P over 3E IAB into 1 minus IAB over IBC into L cube minus capital L cube. So this is the value of maximum deflection of the beam. If you have the value of P, you have E value, you have IAB, IBC, small l and capital L. You can just put it in this formula to get V max. So this was all about this problem 11.7. This is a very lengthy problem indeed, but you have to try it, you have to learn it, and I hope you have enjoyed the video and also learned from this. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.